Good afternoon. So let's look at number 6. What would be the proportion we would set up for number 6? 2.5 over 2. Good. Okay, so this one over this one over this one. You could also do 2 over this and 2.5 over this, as long as like the sides that are touching each other are the ones in the proportion. Okay, so when you're doing this, you're going to distribute 2 to this, and then 2.5 to that. So what's 2 times 2? 4. So 4y minus, what's 2 times 0.25? If you have 2 quarters, how much money do you have? 50 cents. All right, and then what about here? 2.5y plus 2.5 times 0.25. 0.625, I think. Okay, now what? I forgot my y right here. Now what? Add 0.5 plus 0.5 plus 0.5. And also what? Subtract 2.5. What's 4 minus 2.5? 1.5y equals. All right, and then how would I finish? Divide it by 1.5, divide by 1.5, and y equals, I think it's 0.5. Okay, 0.5. And then how would you finish? Go back and plug it in. What if it had just said solve for y? Then you'd be done and just leave it. Okay, you end up getting this equals 1 and this equals 1.25. Okay. This might be 75. All right, 75. Okay, so your proportion can be a lot of different things as long as you keep, like, you're always going to multiply 2 times 2y minus 0.25. So as long as you're keeping your proportion in order, it might be different than the person's next to you, but as long as you start with the right multiplication, you'll get the same thing no matter how you write your proportion. So that's true with proportions always. You have a lot of different options and a lot of different ways to write it, as long as you keep track of where things go. Okay, so how do we use these to solve for missing lengths? So let's take a look at these 2 similar triangles right here. Bianca?
Why is the pineapple bigger than
It must be a statue of a giant pineapple somewhere. Look, here, a student wanted to find the height of a statue of a pineapple in Nambour, Australia. So I guess there is some pineapple statue in Australia, and this student is curious about how tall it is. Okay.
Did you know that I'm scared of pineapple?
No, then I'm sorry about this.
After the one time that I ate it, but I ate too much, I got numb. I was like, no, sorry.
All right, well, I think that's a pretty... I think you can easily avoid that happening again, right? Okay. Oh, well, I would not eat his pineapples anymore. No, she's talking... Yeah. I'm assuming you're talking about a guy like selling fruit. Yeah. Okay. Yeah. All right, can we focus? Okay, so regardless of whether or not this statue actually exists, this girl wants to know how tall it is. The problem is she cannot climb to the top of the pineapple statue for several reasons. If it's a work of art, she probably shouldn't touch it because she could damage it. All right, so instead, she's going to do this. She knows her height. She knows she's 5'4", and then she measures her shadow and finds that her shadow is 2 feet long. And then she measures the shadow of the pineapple and finds that it's 8 feet 9 inches long. How could she use that information to figure out how tall the pineapple is? Yeah, it makes a triangle. So the shadow and the height makes a triangle. So if you use a proportion, you should be able to figure out what the height of the pineapple is. Why would this work? Why would this work?
Because isn't it like the hypotenuse length like longer? And then if you combine the other one, I don't know.
Maybe. What do you mean by side angle side? Okay, yeah, so if they're similar, you know that like here to here is going to be a right angle. How do you know that they're going to be proportional? What causes a shadow? The sun. The sun's angle towards the earth, right? So if it's the exact same time, then whatever your shadow is would be in proportion to every other shadow everywhere. So if it's like 1 o'clock and you have this much shadow, if Maria stood up next to me, she would have a proportionally tall shadow as well. So I'm 5'6". How tall are you? Well, that doesn't work. Somebody else.
4'11".
You're 5'2". So my shadow, if we went and stood-ish. Without your, yeah, probably.
I'm like 5'3".
Yeah, then I am. All right. Okay, good. I'm glad we all know our heights. Now, okay, so if Bianca and I went outside right now and we stood in the same spot, my shadow would be what? Longer or shorter than hers?
Longer.
Why? Because I'm a little bit taller, right? So if we went outside and Ivan, you're 5'7", your shadow would be a little bit longer than mine, right? So because the sun is at the same angle at any point, it's going to create a proportional relationship between this side and the shadow of this one. So that means if we want to figure out a missing side, if I know how tall I am, then I can figure out how tall the statue is. So what would my proportion be here? 2 over 8'9". How am I going to write that? Convert it to feet. So it's going to be 2 and 8 with 9 over 12. Why is it 9 over 12? Because there's 12 inches in a foot. Good. Okay, and then 2 over 8'9", and then what? We could also do that. Well, no, this isn't my x. My x is, I don't know how tall this is. So this is 5'4", and then this would be my x. Because this right here, this 2, is the shadow. So shadow over shadow, and this is height over height. Okay, now, Maria had a question. She said, could we convert them all to inches? Yes. Why would that be easier? It wouldn't necessarily, the numbers would be bigger, but they would be what kind of numbers? Kiara? Because she said she was 5'4". So the 4 over 12 is like right here. It says right here, she's 5'4". What? 4 inches out of 12 inches because there's 12 inches in a foot. But if we convert it all to inches, what would we get rid of? They would all be whole numbers, so it might be easier. So how many inches are in 2 feet? 24. All right, how many inches are in 8 feet? 96 plus 9. All right, how many inches are in 5 feet? Plus 4. And then this is still my x. So now I have a little bit easier numbers to deal with because I'm dealing with only whole numbers. So somebody with a calculator, can you do 105 times 64? Say that again. Okay, and then how would I finish? Divide it by... All right, this answer is in what? Inches. If I wanted to change it to feet, how would I do that? So divide 280 by 12.
23.3 feet.
I don't care. Either answer would be fine. All right, so 23 and 1/3 repeating feet tall. So that's how tall that pineapple is. So essentially every single thing that you might want to know the height of, you can set up proportions to find missing distances. And you set up the same proportion every time. It's like height over shadow, height over shadow. As long as they're lined up correctly, then it doesn't matter if you do shadow over height, as long as both your shadows are on top and your height's on the bottom, or etc. All right, so this proportion can be set up a lot of different ways, but you're always going to multiply these by each other. Rosie. Oh, I have no idea. Pineapple means Australia, but there's pineapples all over like South Carolina because it's a symbol of welcome. So maybe it's like the same thing. Yeah. So people have like welcome mats with pineapples on them. Maybe they really like SpongeBob. Yeah. Okay. So we can also use proportions when we're trying to figure out scales of maps. And we talked about maps before, and we said the reason that you scale maps is because if you had a map that was as big as the actual city, it wouldn't be very helpful, right? So you need to have a little bit of scale so you can get some perspective. So this is a map of downtown Dallas, and the scale is 1.5 centimeters to 300 meters. So what does that mean?
Can't you convert centimeters? No, convert.
You could, but what does that scale mean, though?
1.5 centimeters in a map is 200 meters in real life.
Okay, so if I were to take 1.5 centimeters on this map, if I got a ruler and I measured and this was 1.5 centimeters, in real life, it would actually be worth how much? Okay, and actually it would be worth 300 meters. So if I wanted to figure out then the distance, the actual distance between Union Station and the Dallas Public Library, what would I need to do that? I would need a ruler, and what would I have to do with that ruler?
You see how many centimeters it is?
Centimeters from Union Station to...
Public library.
Okay, so my original ratio is 1.5 centimeters over 300 meters. And then I'm going to have to measure from Union Station to the public library, right? So I start here. And which side of the ruler am I using? The side, so the littler one, the top part of it. Okay, and here's one ruler.
It's because your finger touching the thing.
Oh, got it. All right, I'm just going to hold it here. All right, I'm going to estimate that that's about 60 centimeters. So if that's 60 centimeters, where would that go in my proportion? 60 over x. I don't know what the x is. That's what I'm looking for. So then what do I have to do to solve it? Good. What's 60 times 300? 18,000. Equals 1.5x. And when I divide that, it's what, Ivan? 12,000? So that's 12,000 what? Meters. Good, that's 12,000 meters. So that means to get from the Union Station to Dallas Public Library, I would need to go 12,000 meters.
But isn't like the measurements gonna change if you actually measure it from the paper?
Yes, totally.
I'm so confused.
Yeah. So, but if you did it on a test, you guys would all have the same exact. I'm probably not going to have you do that many problems like this on a test because I don't have enough rulers. So I'm going to give you ones that are like the pineapple ones. But the proportions should still work. Because, yeah, obviously this one is bigger than that one. All right. So these four, go do these four at your boards. Okay, so when you're doing the proportions, like for number 5, how do you know which way your proportion is set up? All right, yeah, you have to look at the angles and the corresponding parts need to go together. So let's say I wanted to do 8 over 12. You can do that as long as in this triangle you do what? 25 over x. Because the 8 and the 25 are corresponding in those triangles, so they would have to go in the same spot here. Okay, so similarity, perimeter, and area ratios. So when you're talking about similarity with any type of triangle, similarity means that the sides are what? Similar means they're proportional, right? So if you reduce them, they will all reduce to the same ratio. All right, the perimeters of the shapes will also reduce to the same ratio. The areas will not. So let's take a look at two triangles. So we've got triangle... Okay, so are these two triangles similar?
Yes.
How do you know that?
You divide by 2.
Okay, so what ratio could you set up? It would be 3 over is equal to 4 over, which is equal to 5 over 10. All of those reduce to what? 1/2. So the similarity ratio then, or the scale factor, is half. All right, what if I did The perimeter ratio. I want to know the ratio between the perimeters. How would I do that? Add them all up. So if I add up the little triangle, what does it give me? 12. And if I add up the big triangle, what does it give me? 24. So what does that reduce to? All right, what do you notice? It's the same. The ratio between the similar sides, so the corresponding sides, is the same as the ratio of the perimeters if the triangles are similar. So if the triangles are similar, your perimeter ratio will be the same. What about area? How do I find the area of a triangle? We call it base times height. Base times height divided by 2. So in this triangle, what's the base?
3
Times the height?
4.
Okay, 3 times 4 is 12 divided by 2 is 6. What's the area of the bigger triangle? What's the base?
6
Times the height? So 48 divided by 2 is 24. What does that reduce to? 1/4. So is it the same? No. How is it different?
It's what do you mean? How do you do that?
How is it different than this?
The denominator is the same.
The denominator is different? Okay. It is smaller in this case. So there's a relationship though, and the relationship is the perimeters are going to have the same ratio. The areas will be that ratio to the second power. Okay, so that ratio to the second power. Why do you think it's to the second power?
Because it's divided by 2.
Not divided by 2. Multiplied by 2, why?
Because
Why?
that gets you that.
What do you mean that gets you that?
Like you multiply by 2, it gets you.
Okay. What's the unit when you talk about the area of something? If I said, how much carpet is covering this floor, what would you say? 50 square units or whatever, right? Why is it square units? Okay. How many dimensions is it? 2 dimensions, length times width, right? It's 2-dimensional. So the floor is flat, it has length and width. But if we're just talking about perimeter, we're just talking about 1 dimension because you're measuring the lines around it. Whereas with area, you're talking about all the space in between. So that's why the ratio is squared. All right, so the same ratio for similar triangles, the ratio squared for area. So that means if I gave you this shape, and I said this is 2, this is 6, this is 18, and this is 54. Are these similar triangles? Yes. So that means what's the ratio of their perimeters? What's the ratio of their perimeters? I'm sorry, not their perimeters, their areas. Well, what do I know about the ratio of the similarity right now? It would be 2 over 6 is equal to 18 over 24. So they both reduce to 1/3, which means that's the similarity ratio. So what would be the ratio of their areas? Not 1/6, 1/9. Why? Good. Area ratio is 1/3 squared, which is 1/9. All right, so 1/9. That's it. So if they ask you what the area ratio is, you can either remember that or you can just find the areas and reduce it. Because it would work the same if I said, what's the area of the small one? 2 times 6 is? 12 divided by 2 is? 6. And then I would have to do 18 times 54 divided by 2. I'm not going to do that right now. Okay? But whatever it is, it's going to be 1/9. So I think it ends up being something, 54. Okay, so area ratio is whatever the ratio is squared. Perimeter ratio has the same ratio. So the ratio of these perimeters would be 1/3 as well. All right, so given that RST is similar to UVW, find the perimeter P and area of UVW. Why are you doing 16 over 20? So that gives you the similarity ratio. So what does that reduce to? 4 over 5. Okay, so 4 over 5 is your similarity ratio, which means that the perimeter will have what? The same ratio. So that means if the perimeter of this is 36, how could I find the perimeter of this? So it would be 4 over 5 equals 36 over x. All right, so 4x, what's 5 times 36?
20.
That's right. Yeah, that's right. From the ratio of 16 to 20. Because you've got to, I'm telling you they're similar. So that means 16 over 20 is going to be your ratio. So you reduce it to 4 over 5 to make it simpler. So the perimeter ratio is 4 over 5, and then divide by 4. What's 180 divided by 4? 45. So the perimeter of this would be 45 feet. Now, how do I find the area? Square what? So 4/5 squared would give me what? 16 over 25. Which is going to end up being 48 over x. So I need to do 25 times 48, which is what?
1,000. No, 200. 200. No, I'm sorry, no. Yeah, 1,200.
1,200 equals 16x, and then divide by 16. 75. So the area of this is what? Like this one? Because we know that this is my original ratio. So the area ratio has to be this squared. So if I do 4/5 squared, that gives me 16 and 25. Whatever you get when you do this side, and reduce it. So like for this triangle, we had 16 over 20, so we did 16 over 20, reduced it, and this is our similarity ratio. So then that's the same ratio we use for perimeter, but with the area ratio, we square it. So how would I find my similarity ratio here? 18 over 5 or 5 over 18. Doesn't really matter. 5 over 18. Can I reduce that at all? No. So that's it. There's my similarity ratio. So what's my perimeter ratio?
25.
Not yet. That would be my area. Perimeter ratio, same thing. And then area ratio would be 25 over 324. 324. Where did that come from? Squaring your original ratio. Perimeter ratio. Perimeter ratio is the same as the sides ratio, and then area ratio is doubled.
But it's only the same.
Sorry, squared.
When it's like this, when it only gives you the base.
When it's a similar triangle. I don't have to give you the bases. I could give you this one and this one too. It doesn't matter as long as, I would have to tell you like this is similar to this. Okay, go try these 3.